Okay. Did you see that? All right. Okay. So the first thing that we're going to do is take notes on a separate sheet of paper. It's going to be on 6-1 angles of triangles. Okay. That should be your first set of notes. So please have a separate piece of paper. 6-1 angles of triangles. In the meantime, let me get you set up, Amina, and please take a look at your cheat sheet. Okay. Okay, so Amina Akbari. Amina Akbari. Amina Akbari. Amina Akbari. And I also have exams too. I just can't find where. Oh, here. Okay, and please, in the meantime, read over this. So you should have. So Yusuf and Amina, make sure you guys grab a cheat sheet in the front. Okay. 6-1 cheat sheet. The triangle angle sum theorem. And please, when someone's ready, please tell me what this theorem basically says. Okay. So Amina, come up here so you can grab your exam. And Yusuf Amanullah, please come up here and grab your exam as well. Yusuf. Okay, there you are. Thank you very much. Okay, so anybody read through that? Can someone please tell me what they have read? What is this theorem saying? In your own words, please. Please don't. Does anybody not want to volunteer? No, cheat sheets are in the front, my friend. Can you give this to Yusuf as well? Thank you. Actually, let me show you guys a more clear picture. So what is that basically saying? Within this triangle, okay, all the angles that make up this triangle, what should they always be equal to if you add them all together? 180 degrees total. Okay, it's not too bad. It's not too hard to understand, right? 180 degrees. So with that in mind, if I gave you a warm-up, could you solve for these angles just knowing that fact alone? Here is your exercise and your warm-up that I want you guys to do. It's actually right in your book. It's pulled right out of your book. But don't look at your book, okay, for the solution here, okay? Given this triangle and the given angle measures, the 20, the 78 degrees, can you figure out what the angle measure is for 1, 2, and 3? What I want you and a partner to do is find a space on the whiteboard, okay? And please, there's a whiteboard there, there's a whiteboard there, there's a giant whiteboard behind you. There are personal whiteboards right there on the countertop, okay? Please grab that, a dry erase marker, and work with someone, please. So Matthew and, let's see, Emily, you guys are going to work together, okay? New partner, right? New partners. Yusuf and AJ. Where's AJ? You guys are going to be partners, okay? I want everyone to partner up, okay? So, Emily, come up here.
Do we need to do all the theorems?
Huh?
Do we need to write the theorems?
No, but maybe tell me, maybe tell me, nah, you don't need to. Just this one right here, maybe. How you figured out first. Don't worry about it. Don't write the theorems, just figure them out, okay? Just tell me what angle 3, 2, and 1 are equal to, okay? You don't have to do a 2-column proof. No proofs. No proofs. No proofs are necessary.
Another triangle.
We just add those two. We just do those two.
Let me come around and help you guys if you guys need help.
I know what I said.
I think that's right. Okay. So 78 plus 61. Wait, no, mine is 4. Yeah, the 78 is 98.
So how did you know?
You know, you're supposed to do it step by step.
You get that too. Yeah, wait. So yeah, so what is what would tell you that angle 2 is vertical angles there?
Yeah. No, I was looking through my test.
Fair enough. Okay, good. On the right step.
Yeah, of course I'm on.
What you guys get that? You guys get angle 82.
Oh, that's 78.
Whoa! If those angles are right across,
Yeah, Matt.
corresponding.
Oh, vertical.
So what do we know about those things?
I got you, Mr. We almost had it.
Very good.
Why do you erase that one?
Good. Very good.
Good.
When you guys are finished, you guys just please leave me the just like Jeremy. Jeremy just left me the answers. So just leave me the answers in plain sight, and then I can check them, and then I will give you the answers.
Yeah.
All right. Everybody good? Let's check your answers. Actually, you can write this down in your first set of notes. Let's check out what the key is. You didn't have to do what I did, okay? But if you want to, it kind of helps to see it formally written. I would actually suggest you to write this in your notes. Okay, so let's just go ahead and write this in our notes, okay? If you got that angle measure 3, the measure of angle 3 should have been 82. You are correct. Anybody get 82? 82, okay. If you got the measure of angle 1 was 41, you are correct. And the measure of angle 2 is correct if you had it being equal to 78. So sorry, I didn't box that. Now without looking, so I have a diagram right here, the sort of the same exact diagram. It's kind of hard to see. What tells us that the measure of angle 2 is equal to 78? What angle theorem is that? What are those angles?
Vertical angle.
They are vertical angles, okay? So due to the vertical angle theorem, or just the fact that they're vertical angles, we know that they're the same, okay? And then if I know that this is 72 and this is 61, what do all three of these angles in here within this triangle have to add up to? 180. So that is why I have this step down here. If you look at it here, the measure of angle 2 plus the measure of angle 1. Technically, this is the measure of angle C to E to D, okay? 61 degrees. Measure of angle CED plus measure of angle 1 and 2 should all equal 180. And we're only really trying to solve for measure of angle 1. If I know that measure of angle 2 is 78 and the measure of angle CED is 61, and I add them together, and then I subtract 139 from both sides, I should get the measure of angle 1, okay? Same goes for the top one. I'm not going to go through this one here, but I just added 20, 78, and measure of angle 3, and I found that to be 82 degrees, okay? Does anybody have any questions so far? Wasn't too bad, was it? Right. Okay, so that will be that. Does anybody else need these notes for a few more minutes? No? Everybody good? Okay. All right. So that is the first part of 6-1, and let's see what we're going to go on to next. Let me see if I have another example for you guys to kind of work on. All right. Do you guys want another one to do? Do you guys want to try another one? One more? Okay. Then I will give you a challenge. Let's see. I think this is doable here. All right. Try this one over here. Okay, watch this, Emmeline. You're going to experience magic. And my hand's still on the paper, but yet they're right here. How am I doing that, right? They still haven't figured it out, right? No one's figured out how I did that. Okay, all right, guys. That's going to be your last one. So please figure out measure of angle 1, 3, and 2. Okay, please go on the board now. Okay, find a space. I noticed no one took the middle space there, so please this time A group of 2 people take the middle space. Please take the middle space.
No, right. We are sometimes amazing. Alright. So you're blind. What did I? What did like in my life. It's like well he can't see and I didn't really happen.
What's 71 plus 50? Do you have a calculator? You can use your phone to calculator. Let me try mental math 120, 70, 77, 71 plus 57. That's 120. Is that 52 or 57?
Where? Oh, that's 57 degrees.
57.
57 degrees.
128.
Mina, did you want to assist Jeremy? I think Jeremy's having problems right now. I'm just kidding, Jeremy. Though it would be nice to have a helping hand, right, Jeremy? Right, Jeremy? Right, Jeremy? Sometimes.
Because it's due to this theorem, these two angles, when you have those two angles, they equal to exterior angles.
See? Could have been saved by Amina, but you didn't ask for help, did you? Measure of angle 3. It is a little bit more accurate to say the measure of angle, so very good. Because when you're talking about angles, okay, and you're talking about measure of angles, you're talking about the actual value of that angle in degrees, okay? When you have the measure of angle, m of the angle sign. So Jeremy, so instead of just saying angle 2, make sure you have m in front of it too. M, yes, for measure of angle, because you're talking about the precise value of that angle. Yes, Alex. Yes, I do. I have your work. Work. X22. Here you are. The last set of the test questions. Too bad. All right. Let's go ahead and check your answers. Measure of angle 1 is 123 degrees. The measure of angle 2 is 52 degrees. And the measure of angle 3 is 29 degrees. So very good. How did you solve for angle 1? How did you solve for angle 1? Can someone just tell me the math that they did for angle 1? What math did you do? Yes, Meredith.
You had to add 57 and the angle of 1, and they both equal to 180, and then you subtract 57 from 80, and you get 180.
Very beautiful. And now, can someone help me too and add on to what Meredith just said? Why is it that the measure of angle 1 plus this measure of angle, technically it's KLM 57, why do they have to add up to 180 degrees? Yeah.
They're supplementary.
They're supplementary, okay? If it's on a straight line, any two angles or however many angles you have, they should be supplementary to each other, meaning they should all add up to 180. Very, very good, okay? Now, let's take a look back on your cheat sheet. Mine's going to have a little bit more color than yours, okay, admittedly. I want you to take a look at this here and tell me what the heck is going on. What is going on here? Based on what you see here. You don't have to describe it in their words. Just, can you describe it in your words? What is the exterior angle theorem say? What do you think, AJ? Yeah.
So basically, angle A plus angle B equals the exterior angle, or those are the two interior angles.
Okay, so you're defining that measure of angle A and B are interior angles. What makes them interior?
Because they're found inside the triangle.
Right? Yeah, they're inside the triangle. Okay? And if you look closely, the exterior angle is outside the triangle here. And notice it's in relation to which angle here? A, B, or C? Measure of angle 1. It's in direct contact, with C, right? And if you think about it, it says that this angle, right? Well, actually look at it here. measure of angle C and 1, what are they to each other? What should they add up to?
180.
180, right? And then if you think about it, measure of angle C plus all the interior angles in here also add up to 180, right? So just think about it closely. Whatever this angle is here should be the same as the other interior angles, right? If I were to show you the math, it's like it'll come out very nice. It'll be like the transitive property. You don't have to write this part down. All you need to know is that exterior angle outside of C should be equal to the sum of the other interior angles. But let's see why. It was funny, a student actually last year pointed this out to me. For me, it was rote memorization. And I just realized that what she said was absolutely correct. She stumped the teacher, which I guess sometimes isn't that hard to do. In this case here, okay. Let me recreate this, all right? Mr. Wade, the master of shapes, right? No, no one agrees with me. Okay. So if you think about it here, you have the measure of angle C plus the measure of angle B and plus the measure of angle A is equal to 180 degrees, correct?
Yeah.
Also, the measure of angle C plus the measure of angle 1 on the outside is also equal to 180 degrees. If you look very, very closely, right? Here and here are the measure of angle C, right? But look at this. Wouldn't you say that these values are exactly the same thing? Whatever is left over, right? Measure of angle 1 or the measure of angle B plus measure of angle A, okay? Whatever is left over, okay, meaning the other two interior angles, it should be the same value as measure of angle 1. Does everybody see that? That's how it mathematically works. Or if we had to be really technical, we could subtract the measure of angle C from both sides here and here. You don't have to, again, you don't have to write this. This is just going to become a mess on your paper. You're going to be like, I don't know what we just did in class, okay? But if you think about it here, it's both of these guys are equal to 180 minus the measure of angle, 180 minus the measure of angle C, and so does the measure of angle 1. It also equals 180 minus the measure of angle C, okay? So whichever way you cut it, these two should be the same. The interior angles are going to be equal to the exterior angle, okay? Any questions on that? Were your minds blown, young children? No? Jeremy's just looking down saying, I guess not. Nope, I guess not. Okay, fair enough. Okay, let's go on to the next set of notes. Well, it's going to be a sample problem, okay? So we're going to continue our notes on 6-1, okay? The subtopic this time was the exterior angle theorem. And then I'm gonna provide you with an example, and then we're gonna solve this together, okay? The exterior angle theorem, and then an example of this. Yes? Oh, sorry. Okay. And next, another skill I was going to assess you on was, can you read between blurred lines? I guess you failed. Oh, you good? Okay. Oh, nice save. Okay, I'm just kidding. Okay. So you need to find the angle JKL in the triangle below. All right? I'm going to draw a straight line, and I'm going to draw 2 points on the triangle. Okay, kind of spread apart, not perfectly in any way. Okay, and I'm going to draw it to another point there. That's my triangle. I'm going to name these individual parts. This dot out here, sorry, I just drew in another dot. It's going to be J. This one's going to be K. This one's going to be L. And this one's going to be M. And then this angle right here, I'm going to draw an arrow saying that this angle here is 2x minus 15 degrees. Technically, all of this in degrees, okay? 2x minus 15. I apologize. That's 2x minus 15. This is x degrees in here. This internal angle is x degrees. And then over here should be 50 degrees. I want you to find the angle of JKL. So how could we set this up? I'll start with this. I'll say that the measure of angle, yeah?
Was that plus or minus 15?
That's minus 15. Sorry, 2x minus 15. Mr. Wee's gotten a little bit addicted to these felt pens, but at a cost of not writing as good as notes as I did with the sharper pen. So my apologies. I'll have to write bigger. Okay. So if I think about it, this is angle JKL, right? The measure of angle JKL. What can I say about the measure of JKL? What is it equal to?
It's equal to 50 degrees plus x degrees.
Okay, and let's be a little bit more formal here. What are they actually called? What is the angle that has 50 degrees?
Angle M, or LM.
Yeah, LMK.
Angle KLM.
KLM. Beautifully said, Colton. That was beautifully said. So we know that 2x, and now we could substitute 2x minus 15 is equal to 50 degrees plus x. Can we solve for x here? What do we do? Now Mr. Wee's lost. I don't know what to do now. Matthew.
You add 15 to both sides and subtract x to both sides.
Okay, add 15 to both sides. So I have 2x is equal to 65 plus 15, or plus x. And I subtract x from both sides. X is equal to 65. Is that my final answer?
Nope.
So what am I trying to find out, though? What am I actually trying to find? Yeah, Matthew?
The angle of JKL.
So the measure of angle, we know that the measure of angle JKL is equal to 2x minus 15. So what does that mean? Or what does that mean I'm going to do with this value here? X equals 65. What did I just solve for? Yes.
We're going to substitute x for 62.
So 62?
5.
65 minus 15. Let's see if anyone can do this internally. That's yes.
150.
That is correct.
15, not 50.
Okay. This is your final answer. Does that make sense? Yeah? Okay. I think you guys are ready for a challenge. Yes? Okay, this is... I want you to solve for the value of x. Okay, so find a whiteboard space and find the value of x. And ask yourself, wait a minute, Mr. Wade, is there something weird here going on? Okay. There is something funny about this problem that I just gave you. Oh, it's not just x. Find me x in the angles 2 and 3. What are angles 2 and 3? 1? Is that what you say?
What?
Do you say 1?
No.
Oh. Fair enough. Okay, I'm going to walk around, see if anyone needs help.
I said 37.
5x plus 62. What's 5x plus 62?
I'm just so happy.
Yeah, and you're going to do the math. That's not a 5. Oh my god. Alright, you do it. So that one is 5x.
Yeah.
27 plus 30.
It's a miracle.
Sorry, we'll call this. Yeah, we'll call this y. Or angle y.
No, you wrote 8.
Well, I thought I had to go
This one or the inside?
But first we need to find x. We don't even know what x is.
This is.
Get behind it.
Define x.
I should add it all together.
So you, okay, so you end up just adding them together. So
That's just add.
no, I want that. There's a nail.
Yeah.
Good first impression. Hey, students.
Grab the name. 118. X is equal to. I wonder where that's from. Maybe like a 23.6.
Anybody need help?
Okay, what's 23.6 times 3? Can you do that in your head?
Let me see.
I think you got it on.
Yeah.
70.8.
So his the x should be a whole number.
Oh, we're just talking crap.
And this is we have question. 154.6. That seems super odd.
Dude.
Give me 1 second.
Okay, Mr. Ray, I have a question.
So.
Mr. Wade?
Did you guys get a decimal answer?
No.
No. What'd you guys get? What'd you get for x?
62 plus
Oh,
30.
okay, you got 4.
What's this? 3x plus 47.
Yeah.
37.
Let me do this on my own too. Let me see what happens
Can
here.
you do this in your calculator? 62 plus 47 plus 37.
I got one wrong.
They're 47.
Oh my god, you got one wrong. Shame upon you.
Yeah.
I got that. Shame.
What's that? 146. I don't get why I got that one. Yeah.
What's that mean? How are you?
X is equal to a more reasonable 4 point.
Oh yeah, you guys are right.
47 to 37.
Absolutely.
You got a decimal answer still on.
Yep, yeah, it should have been a decimal answer. So we're gonna go with.
Okay.
Huh? Sorry about that, guys. What is x? What'd you guys get for x?
4.25.
Okay, 4.25. We're gonna go with that.
134.
Yeah. Okay, that's 4.25. The measure of angle 2 then would be equal to 3 times.
That's 4.
Okay, what else? What did you guys get for measure of angle 2?
Okay, here it is. 4.25 times 3. Can you do that?
Yeah, no, it works. Yeah.
Okay. And measure of angle 3. Can someone give me the measure of angle 3?
96.7? That can't be the code. That can't be correct.
You weren't bad. You should just
It's okay, yeah. The numbers look really funky. 96 point what? 27? Wait, what'd you get from it? 83.25.
Like a 96.75.
How did you get that?
Let me see. What's the
A lot of things are hard.
37.
9.75.
Yeah, what's 4.25 times 12.75? No, 4.25 times 3. Okay, 12.75. Yeah, 96. Yeah, this exterior angle is a measure of 96.
Let me see what else you guys get. So you guys should get decimal answers. I apologize. I didn't intend for that. I thought it was going to work out cleanly, but it did not. So my apologies. I'm going to check with the calculator really quick. This works out. Just to double check.
I had a really horrible answer, 96.75. I don't know if that's correct.
Let me see. So you have 34 divided by 8 here. We get 4.25. So you guys should have gotten, let me see. So this is my work in progress right now. I'm checking to see if, yeah, it's 4.25, but let's double check and see if your measure of angle 2 is 59.75. That's 3 times 4.25 plus 49, or whoops, nope.
What about the exterior angle?
42 plus 62, I'm sorry. Nope.
Okay, that is correct too. That's 59.75. And measure of angle 3 is 5 times 4.25 plus 62. That is 83.25. Okay, so very good job if you guys got these answers. My apologies. One more question, right? This is for extra credit. Can someone find me the measure of the interior angle or the exterior angle, exterior to angle, measure of angle 3, really quickly? How can you find the exterior angle? You and a partner can get some extra credit points.
96.75.
96.75. That's what I got.
Matthew is literally the only one with his hands raised, though. So, Matthew?
96.7.
Okay, so the measure of the exterior angle should be 96.75. So, Matthew and Emmeline. So, Emmeline, you're not enrolled quite yet, but you would get extra credits. I'm going to make note of that. Can someone tell me how they did that? Meredith.
Add 1 and 2 together by the exterior angle here.
Very 1 and 2. Sorry, that's 1. This is 2. Very, very good. Meredith and Miss Scorio. Okay. I know you're not supposed to say it like that, but I for some reason I just like Scorio. Okay, very good job, guys. You guys are very, very impressive students. Okay. Any questions on the exterior angle theorem? I think you guys pretty much mastered it. Yes? Okay. Let's see if we can go on to here. Nope, that's not it. Okay, so I believe on 6-1, there's also these corollaries here, but we don't really need to go over these. Okay, I think they're pretty useful, but we're not going to really use them in proofs or anything in the future. Okay, for the corollaries. Over here, however, I want you to go on to 6-2 and have a look at these polygons or these triangles. Okay, it's fairly simple. Sort of like what you guys learned about corresponding angles and corresponding parts. Okay, it basically just says two angles are congruent to each other if their corresponding angles and corresponding sides are congruent to another set of corresponding angles and corresponding sides. Okay, or they're congruent to a set of sides that correspond to the other on another triangle. Sorry if I kind of mixed that up a little bit. Okay, so let me see. If you look at it here, right, without looking at the answers, if you can avoid that, right, so just imagine Mr. Weeks blocking all these, okay, just by looking at these dashes and these hash marks and these little arcs here, could someone please tell me which side on this triangle corresponds to the side on this triangle? Or which side does this correspond to in this triangle here? Emily.
Well, like the one with the 1 dash would go to the 1 dash of the other one, and then same with the other ones. Like the 2 dashes would go to that one. The 3 dashes would go to the other 3 dashes.
Okay, very good, very good. So we know that technically we would say line segment A to B. So be very careful. I would use these as placement markers. Okay, so the naming convention is very, very subtle but very important. So this is technically A to B. Notice that it kind of starts where I started this line segment from A to B, right? I just arbitrarily said that. A to B is congruent to, pay attention, I would use these as a reference. You see how I started from this point here and it has an angle with 2 arcs here? I would start with the angle from 2 marks here. We know that this is corresponding to HJ or JH. How you would say that is A to B would be corresponding to what? J to H or H to J? So if I name this A to B, what is the corresponding line segment on this triangle?
HJ.
It's H to J. Because remember, like it's really important because we know that tells us that the triangle is kind of flipped upside down. But regardless, we just know that A to B is congruent to H to J. Okay? How about this? Angle BAC. Back. Or back, okay?
The angle JHK.
JHK. So let's see if that's correct. JH. J to H. Nope, that is. Oh wait, yes it is. B. Yes it is. Oh, I apologize. Okay. And how about angle BCA? Who is he congruent to? Or she, or whoever. That angle is congruent to. BCA. Who are they congruent to on this triangle? Okay. Alex.
JH.
J to H to K?
Yeah. No?
Not
Or-
quite. So this is BCA. That's the angle we're looking at.
Oh, so it would be JK.
Yes, very good. Okay, there you guys go. Right? I think they actually got kind of lazy, huh? So A is just equal to H and then B. You guys can do that too as well. But I like that you guys were really subtle in detail there. That's what I love about you guys. Okay. All right. So knowing that now, let's just do a quick exercise. You can do this at your desk now. Copy these. Sorry, I know this is very hard to see, but
Alright, let's see here. My drawing is
let me see if I can overwrite this here.
non-existent.
This is 2 dash marks. This is 3 dash marks. This is 2 dash marks. This is 1 dash mark. I want you guys to give me all the corresponding angles and all the corresponding sides. For the angles, you guys can go a little bit lazy, okay? And you guys don't have to necessarily say D to GR. You could just put angle G, angle D, angle E, single angles, okay? So I'll give you one. So angle P, let's say, or actually angle S. Who is angle S congruent to? Who is angle S congruent to? On this other polygon. From this polygon to this polygon. Who is angle S congruent to on this polygon? What did you say? D? Yes, that is correct. So can you guys give me all the other pairs and all that? No.
No, I have a question.
Yeah, go ahead.
Got it. Do you have 2 R's on there?
Oh, dear. Someone give me another letter here.
A.
Q.
Q's already here. So,
B. Z.
Z? You guys want Z? Would that make it easier for you guys, or? Okay. Oh, we're just gonna keep it A. I don't have white out here, so. Oh, I do. Yeah.
The far right line on the bottom one. Is that the line?
Oh, I'm sorry. Where?
That one? The other shape?
Oh, so let's see. Hold on. Oh dear. Did I mess this up?
No,
Yeah.
you said that's the same.
Yeah. Hold on. Wait. Give me 1 second. Let's see here. What do I have here? What did I do wrong here? Let's see. Do something wrong here?
You have to put them all in the right order.
Is S B supposed to be congruent to 2 R?
Yeah. Hold on. Sorry, guys. Mr. Wade just done goofed here. So here should be 1. It's gonna be 1 here. Yeah, this doesn't work, does it? Let me see if hold on. I think this is not accurate. Let me just pull. Oh, here, 345. Sorry about this, guys. 345. Oh, here it is, guys. This is better. Okay, here. Oh wait, yeah, it is meant to. Yeah, I'm not gonna. Here, I messed this up a few times, but actually, a few things are gonna be congruent to each other, guys. So I want you guys to tell me all the line segments that are congruent to each other. So this is the actual one in your book here. I want you to tell me all of them. So notice that D and E are congruent as well to E to F as well. So you can say that DE is congruent to E to F, and then who are they congruent to on the other polygon as well? Okay, can you guys do that? Okay, all right, take a few minutes to do this and solve for this, okay? Tell me everything that's congruent to each other and all the angles that are congruent to each other as well, okay? Take a few minutes to do that. So the only way that you guys can prove right now, to your understanding, 2 polygons are congruent to each other, if you can show me which parts are corresponding. Every angle on this or on one polygon has to correspond with an angle on the other polygon, right? As well as the line segments as well. If you can prove that in 2 different polygons, you can successfully say they are 150%, okay, 100% congruent, right? That's the only way you can prove that right now. Okay, to your understanding right now. Just a sneak peek in the future, though, there are shorthand techniques that you don't need to prove every single pair of angles and every single pair of line segments are congruent to each other. This is a lot of trouble to go through, right, to do this. But right now, the only way you can prove two things are congruent to each other is you have to say that every single angle has a corresponding angle on the other polygon that is congruent to each other. And every single line segment has a other, or is congruent to another line segment on its corresponding polygon. Okay. Just show the book.
The one thing that I don't really like is it has to be in the right order. They have to be in the right order.
Yeah, they do. Yeah. Or you don't like having to do that?
Yeah, it's always confusing.
Yeah, it is. Yeah, it is very confusing. Yeah. To be honest, guys, it's okay. If your order is incorrect, like D to G and isn't like and you say D to G is congruent to, let's say, P, let me see, what's it incorrect? P to S. I'm not going to take off any points for that, okay? But it's just another added layer of complexity, but also another added layer of accuracy. But you don't have to be that accurate. I'll get the idea on what you're saying then in the future. So like on the test, if you say D to G is congruent to P to S, even though it's not the exact order, it's fine. So AJ, to clarify with you don't have to be exact, okay? So as long as I kind of get the idea of what you're doing, I'm like, all right, okay. They clearly know which parts are corresponding with which. All right, you guys want to check your answers? All right. So just for the parts that are corresponding, you could say more, but here's some of the things that you guys should have mentioned. At the very least, you should know that at least P is congruent to angle G, right? Q is congruent to angle F. R is congruent to angle E. I think the angles are a little bit easier. And the angle S is congruent to angle D, okay? So let's look at, so here are the line segments. And let's just skip ahead right here to FE and QR, okay? Who else are they congruent to as well? Yes.
RS and ED.
RS and ED. So technically, these two pairs over here are actually congruent to each other as well. But the book only mentions the ones that are quote-unquote corresponding, okay? Just a coincidence there. All right, so I think you guys are good with this, right? Now let's apply some math to this. Let's apply some math. So we're still on 6-2. Now this is back to our paper notes here. 6-2, okay, for congruent. So we've been doing congruent triangles. 6-2 congruent triangles. Here are two, what is it? Triangles here. Okay. This is a good exercise in someone who can't draw well, but means to draw that they're congruent, okay? D, E.
Are they supposed to be congruent?
They are supposed to be congruent, okay? So I will say this. In this diagram, triangle, whoops. Oh, that's not what I want. Nope, that's not what I wanted here. Okay, that's enough. Okay, that's fine. Return. Okay.
Is the bottom triangle supposed to be bigger than the top one?
No, it's not. Okay, so in this triangle ABC is congruent to triangle DFE. Notice I was very particular about the order. A to B to C is congruent to D to F to E, okay? Your task will be to find X and Y. But wait a minute, Mr. Weir, I don't see an X and Y on here. Let me show you where they are, okay? This side, FE is 2y plus x. That's how long it is. It's 2y plus x. This side over here is 38.4 from B to C. Hint, hint, that is a clue, okay? This side over here is 32.1. Oops, I'm sorry, wrong one. That's a 32.1 should be on A to B. I apologize. Okay. This angle in here should be 99 degrees. I know that's hard to see, but that is a 99. That's not 77, that's 99 degrees, okay? This is 36 degrees over here. This one is 45 degrees down here. And then in here, this angle at the very top is 8y minus 5. Do you think you can solve for these variables? Absolutely. Okay. This time I want you guys to be up and about, okay, figuring out this problem, okay? So please now go to a whiteboard space. You can mix it up. You can try a different space on the board now. So how about we do that? Everybody please find a different spot on the boards to mix it up a little bit. Find a different spot on the boards, okay? You and a partner, okay? Find a different space on a different board to work on. Find X and Y.
You know what?
All right.
Find X and Y. I think you'll need the
Sorry, if you guys can't see this. Here.
zooming in just loses image quality usually.
Yeah, it typically does, but this is at its highest resolution, I think. If you zoom in anymore, it just gets blurry, I guess. But yeah, typically if you zoom in too far beyond the resolution, I guess, capacity, I'm not sure how to properly describe
I
it.
think only cameras can
Is
zoom
Y 13?
without losing quality. I think most cameras whenever you zoom
Maybe.
in, you lose quality.
Yes.
Okay, because this the computer and it's towards X. Oh, there's a Y.
I mean,
Huh?
This is an extra Y.
That's plus X. 2y plus X.
Is that angle F 8y minus 5? Yep. And what's that? 49 or 41?
That's a 99. 99. That is 99.
Go ahead. Y is equal to 13. And so X is equal to 38.4 minus 26 is
12.4.
Yes. X, you should get a decimal answer. Y, you should get a whole number. Oh, don't worry. It's not your fault. I apologize.
Oh Lord, you've done it again. It almost didn't does that.
Are you guys okay?
I already got it.
Well, Matthew said it.
I solved it before, Matt.
You guys don't like that.
But yeah, we know we got the same answer.
Yeah. Okay. Put it on. Yeah. Okay. Go ahead and work on it. This is.
I'm ashamed like you
Take
do.
away now.
I'm
Here.
ashamed.
I'm good.
Yeah, it's perfect.
Lift your stuff.
No offense,
feel
no
like
offense,
that.
Mikey. Wait,
I'm not gonna get married.
Oh, you guys already finished your work?
don't get married too young.
Are you gonna be a single guy
Pringle?
who's
Hopefully
just
this is
living
interesting.
in his house like living left on? No, it sounds like a plan. throwing a couple cash. Maybe
Right
get
on the
iguana.
beach, right on the beach with like your hippie beard and
Right,
like
maybe
Just
get an iguana.
Yeah.
Iguana.
I think it's correct. I don't know if it is.
A man with somebody else's plan.
I see with the key. I'm just kidding. Did you just need to check the answers? Is that why?
Oh no, it was
Oh, falling off.
Be lame and square. No, I'm gonna do something quite wizard as a matter of
All right, guys. You guys want to check your answers? Okay, if you want to take notes, here is a more formal way to do it. Here's the solution. Okay, what happened to my extra credit paper? Okay, here we are. Okay, so for you to say that F angle, just a quick reminder. So Y, you should have gotten 13. X, you should have gotten 12.4. You need to solve Y first. Okay, guys? No. Okay. You should have gotten Y first because we don't want to mess with some guy that has two unknown variables. So we want to at least solve for one of the other variables. And we know that the measure of angle F is equal to the measure of angle B. Okay. But if you wanted to kind of define that, going back to proofs, we'd have to use the corresponding parts of corresponding triangles. That's an old theorem from one of the first sections that we went over, okay? And then in order for you to go from congruence to equality, you have to use the definition of congruence, okay? Because whatever is congruent to each other is also equal to each other as well. Here I said the same thing. You guys probably, once you guys found out Y, you guys knew that you could just plug in Y here into 2Y plus X, which is FE. You said that the line segment FE is congruent to the line segment BC. And then I actually just kind of said that is actually defined by that is justified by using Cpctc. Does anybody know what that stands for? Does anyone want to take a stab at what that stands for?
Corresponding parts of congruent triangles are congruent.
Yes, corresponding parts of congruent triangles are congruent, okay? And that should have been 12.4 once you did the math, right? Any questions so far? I'll leave this up for a few more seconds if anyone wants to take this as notes. We're going to go on to 6-3, which I'm impressed. We got there fairly quick. I didn't think that we'd get there in this good time. Okay, we're doing that. Yes, you are. You are very cool. Okay, very, very cool. Very cool. Very cool, guys. Okay. All right, let's go down to this part over here. 6-3. So in 6-2, I said that if you wanted to prove that two triangles were congruent to each other, you had to prove every single angle and every single line segment was congruent. But look at 6-3. What is it saying now?
We don't.
SSS. You don't necessarily. Hold on. I want to give this to someone else really quick. Colton, why do you say not necessarily? What is it saying here?
Well, because it's just the sides. You don't have to do the angles.
Yeah, all three sides, right?
Yeah, well, that's what has 3 S's.
Yeah, that's why it has 3 S's. First side, side, side. If you can prove that there are 3 sides on triangles on one triangle that are congruent to the 3 other sides on the other triangle, because there's only how many sides on a triangle? 3, right? Then for sure they should make a congruent triangle. If you don't believe me, you can do 2 triangles that have the exact 3 sides congruent to another 3 sides, right, in the same order, and then you can measure the angles if you wanted, and they should be congruent as well. The corresponding angle should be congruent as well. Okay, someone figure that out. Right? Sounds pretty just something that sounds pretty rare. Sounds something like you could just take for granted, but don't take that for granted. Okay, someone saved you a lot of time in proving triangles. So that being said, notice 6-1 and 6-2 do not have proofs.
Yay!
6-3, however.
Aw, man, you spoiled it.
Oh, I thought you were going to say something much meaner than that, Colton. But thank you. I appreciate that. You spoiled it is good enough. That's fine. Yeah. If I spoiled your fun, I apologize. Okay, so that is side theorem. So let's do a proof. Aren't you guys excited like I am about proofs? No. Okay. Why are you guys not excited? You guys did really well on your last exam.
Yeah, but they're lame. Proofs are boring.
Oh, proofs are.
They take a while.
They take a while. Okay, all right.
I come to math not to learn how to spell.
What? Is that what you learned from this exam?
Yeah.
All right.
For those who cannot speak learned letters.
Okay, excuse this. Okay, proving triangles.
Mr. Weed, your computer needs to put on his glasses.
Oh, you know what? They
See what I did there?
Sorry, folks. That's indicative that my pen is dried up. I'm gonna go back to a red pen, standard red pen here. Okay. Okay, 6-3, proving triangles. Congruent. Okay. Here's a little sneak peek. We got SSS, and then we also got this weird thing called the SAS. Oh dear. What do we think that could mean? Don't say it. I'm just saying, what do we think it could mean? Who knows? Who knows? Okay, here's another little thing that I want to bring up here. Your book is very interesting. It's telling us to write a flow proof.
What's that?
I don't know. Okay,
Oh.
that's why I'm going to tell you right now. We don't need to do flow proofs. Okay. I would rather you do the 2-column proofs, but if you really love flow proofs, I'm not going to take that away. You can do flow proofs if you want, okay? I'm going to ask you to do a 2-column proof, but you can do a flow proof, all right? If that works better for your brain, okay? So that being said, I'm going to give you this problem here. Okay, so I'm going to ask you to write, your book might ask you to write a flow proof, okay? Okay, write a 2-column proof. Here's the triangles. I'm going to draw a straight line. I'm going to kind of draw a midpoint here, like somewhere in the middle. And then I'm going to kind of draw 2 equally spaced points out here. And I'm going to connect to them. So this is what you should have on your paper. 2 beautifully drawn triangles. Almost as beautiful as Mr. Wee's, okay? Admittedly not as good as Mr. Wee's, right? This is just glorious. I'm just kidding. You guys are much better artists than myself.
Are they supposed to be congruent?
Yes, they are, okay? You know, I do take that offensively. It just insinuates that I'm not
No,
drawing.
I'm asking you.
Okay.
If,
I know.
it might not be.
They look great, don't they? Right?
They look beautiful, Mr. Weed.
Thank you.
Almost as beautiful as mine.
Oh, okay.
Why? You gotta ruin
Those are
Wow, this is
words, my friend.
hateful.
All right. Given information, here are some things that you must know. GH. Now, here's the thing. Actually, Matthew, the fact that you asked me that was a good question. We don't know if these are congruent. They might be
But
congruent.
they're supposed to be drawn as if they look like this.
Sort of congruent, but we just don't know if they are. So here's the things that we know for sure. GH is congruent to KJ on the other triangle. On this triangle here, GH is congruent to KJ, okay? Then we also know HL is congruent to JL. And L is the midpoint of GK. Those are 3 known things. Here's what we got to prove. We want to prove that triangle GHL is congruent to triangle KJL. I will help you with this first proof. You're not going to like it only because it's going to seem redundant. This first column is statements. Does anybody remember the other column and what that is? Reasons or justifications, okay? So, Emmeline, yours might have been a little bit different, but it's the same setup. Yeah, statements and reasons are about the same, okay? All right, so here is the part that you must start with. You must start with what's given to us. What's given to us? What things are given to us? I'm going to call on someone random. Georgia, can you tell me what's given to us? Like maybe one thing that's good. Okay. Is congruent to KJ. Very good. Can anybody else tell me what else is congruent or what else is given to me? Colton? What else is given to me?
That HL is congruent with JL.
Okay. And then I know it's fairly obvious now, but for some people maybe it's not, so it's good. So we can kind of help each other out. Can someone give me the last bit of information that is given to me? What is given to me? Jeremy, what is given to me? What else is also given to me?
How was the midpoint of GK?
GK. Okay, so we have those three. We can do it as bullet points there, okay? I'm just modeling for you how I do things, okay? So those are like little individual bullet points. You don't have to do this, Emily, just to be kind of, but you know, you can. It's just helping. Okay, now what do you think we could say now? So we got two sides. We have SS, if you think about it. We have two pairs of sides that are congruent to each other. But we need a third to use this new SSS, this newfangled SSS theorem. But how can we figure out that last pair of sides that are congruent to each other? So I want you to think about this, okay? But you know? You know, AJ? How do you know? Okay, AJ, what do you know?
Okay, so L is the midpoint of GK. And then by the definition of midpoint, GL should be congruent to KL.
Oh dear. GL is indeed congruent to KL by what reasoning?
The definition of midpoint.
The definition of the midpoint states that if you have a point in between two other points that make a line segment, it splits it up into two equal line segments by the definition of what is a midpoint. I put def, abbreviated def with a dot at the end or period at the end, def of midpoint. The definition of the midpoint states that. Okay. If we want to be more accurate too, GH, I'm going to put 2 dash marks here, and then HL will have 3 dash marks, and so will JL. Okay, indicating to me the corresponding sides that are indeed congruent to each other. Because now, if I have all 3 sides being congruent to each other, what can we say now about this triangle? These triangles. Yes.
They're congruent.
Yes. Okay. The triangle GHL is congruent to triangle KJL. My reasoning, thank you very much, Fenna, is by the side. What is it? Congruence theorem, I believe. Yeah. Congruence theorem. Congruence theorem. There are many ways you could abbreviate this. You could write it all out, side, congruence theorem. Or you could do SSS, congruence theorem. You can do SSS, the congruent sign, THM for theorem. Sorry, these are just options you guys can do. You guys don't have to write this down. Or you guys can just put SSS. You pick your poison. Okay? That is a poison. I'm just kidding. It's not a poison. Math is not poisonous. Okay? Math is not poisonous. Would you guys like to try one? All right. Actually, I'm just going to go through another theorem really quick. And then I don't know if we'll have time to go through another one here. Okay. The SAS. SAS theorem. It's sassy. Okay. What is this sassy theorem telling me, folks? What is this one telling me? It's not sassy molasses. You can call it that, but it's just the SAS. Side angle side. Okay. And what does that tell us? Oh, hold on. I want Yusuf to tell me now, Yusuf. Yeah, Yusuf. Yeah, Yusuf. Can you give me a thought about what SAS means? What is that?
Oh, we say that side.
Uh-huh.
And other side. There's an angle between the sides.
Uh-huh.
And it's the same on both triangles if we do it.
Okay. Beautifully said. Okay. Very simple. If you can define a side that is congruent to the other triangle, and you can define the neighboring, it has to be the neighboring angle, okay, to that side, and you can sandwich it between another side that is congruent to the other side of the other triangle, okay? They have to be corresponding in this exact order now. Now order really matters here, okay? Then you can successfully say these two triangles are congruent. This is another shortcut, all right? Think of the SSS and the SAS as shortcut theorems to defining that two polygons or two triangles are congruent to each other. Instead of having to prove every single angle and every single side is congruent to each other. You don't want to do that. Or maybe you do. I don't want to take that away from you, okay? If you're that much in love with the process of the math, you can do that too. But I infer you can take some shortcuts to define that two triangles are congruent to each other. Is that understood?
Yeah.
Okay. It is officially 10:31. I don't know if we have enough time to do another one. Would you like to try one, or would you like to pack up and leave home today? You guys would like to leave home today? Okay. Well, I will leave you with one problem in case you want to do it. You want to try it, but you don't have to. Okay. This would have been the final one. Okay. This is page 356. Is 10:32. You only have 3 more minutes of class, but you could try this one. This is good practice in here. It is these two triangles here. These two triangles here. This is what you know about them. I'm gonna zoom out. You guys can read this, okay? Knowing just this alone, can you solve this problem? It's okay if you don't want to do this. It's fine. It's absolutely fine. Okay. Otherwise, take care, and you guys have a great day. Hopefully, you guys have enough skills to start with for your homework. Thank you guys for coming to class.
Sorry I was late again for the class.